Hey guys, let's talk about probability. So just some probability basics, sample space. All possible outcomes is your sample space. What are all the possibilities that can happen? Okay, so you're gonna see some notation. P of A means probability of A or event A. Okay, so first rule, the probability of event A must be between 0 and 1, including 0 and 1. Okay, 0 meaning it's impossible, and 1 meaning it's certain to happen. Okay, rule number 2, sample space must add up to 1. All possible outcomes must add up to 1. Probability. So the probability of the sample space is equal to 1. Okay. And we have a complement rule. Okay. The complement is different. Notice the difference in spelling, not like I give you a compliment, but the complement rule is the set of outcomes not in event A. Okay, set of outcomes not in event A. All right, so for example, the probability of the complement of event A is 1 minus the probability of event A. Okay, you know, if you're thinking about like a number cube, which we're going to get into, the probability of rolling a 6. Well, the complement of that would be the probability of not rolling a 6. Okay. All right, so let's look at some examples and start wrapping our brain around this. As the probability of rolling a 5 on a 6-sided die is 1 out of 6. Well, the probability of the complement of rolling a 5, which is 1 minus 1 out of 6, which is 5 out of 6. Okay, so that's how complement works. Some probability questions are much easier to answer using the complement rule. Okay, let's look at example 2. It says Tim has been an 85% free throw shooter for 3 years. The probability he will miss the next free throw. Okay, so we have what's called the addition rule. Okay, the addition rule. So the addition rule states the probability of event A or event B. And the formula is you take the probability of event A plus the probability of event B. Okay, if A and B are what is called disjoint or mutually exclusive, that means they cannot happen at the same time. Okay, if they are disjoint and they can happen at the same time, okay, then the formula is a little bit different. Okay, so if they can happen at the same time, it's the probability of event A plus the probability of event B minus the probability of event A and event B. Okay, that's a little bit of a notation, and. All right, so the probability of event A plus the probability of event B minus the probability they both happen. Okay, if they're not just disjoint, or they can happen at the same time. Okay, so example 3. Okay, oh, we forgot to an example 2. The probability he missed the next free throw is 15%. So if he makes his make percentage 85%, probability misses is 15%. So let's look at example 3. It says rolling a 6-sided die is a probability you roll a 5 or you roll a 3. Okay, so a probability of a 5 is 1 out of 6, or in your head you should start saying or means add, or means add. 1 out of 6, they cannot happen at the same time, so we simply just add them and reduce. If they could happen at the same time, then we would have one more part of the formula. Okay, let's look at example 4. It says, during the last election, Democrats represented 46% of the populations. Republicans represented 47%. And independents represented, well, 46% plus 47% plus your independence has to equal 100%. Okay, so it's just some simple arithmetic to get the remaining 7%. What is the probability that a person selected at random is a Republican or a Democrat, or an independent, sorry. 47% Republican, or means add, 7% independent. Okay, they are mutually exclusive, meaning they cannot happen at the same time, so 54%. Okay, all right. That was the addition rule, or means add. Multiplication, okay. We have the probability of event A and event B, okay. Take the probability of event A times the probability of event B. If the events are independent. Okay, independent, definition of independent, if one event does not affect the other. Totally independent, all right? So let's look at example 5. So suppose you roll a 6-sided die 2 times. So we have 2 events, event A and event B. Probability you roll a 5 on the first and roll a 3 on the second. Okay, so a probability of rolling a 5 is 1 out of 6. Probability you roll a 3 is also 1 out of 6, and you multiply them, so you got a 1 in 36 probability, 1 in 36 chance of rolling a 5 on the first roll and then a 3 on the second roll. Those are independent because they're independent rolls. They don't affect each other, okay? Suppose you roll a 5 on the first roll and don't roll a 5 on the second roll. So probability of rolling a 5 is 1 out of 6. Probability you don't roll a 5 is 5 out of 6, which is 5 out of 36. Okay. All right. Going back to Tim, shooting free throws. 85% free throw shooter for 3 years. Okay. So what is the probability that he will make the next 2 free throws? So the probability make and make. So you got 0.85 times 0.85, 0.7225 is the probability he makes the next 2 free throws. Well, what's the probability he makes the next 5 free throws? Well, that's 5 in a row. So basically 0.85 times itself 5 times, which is to the 5th power, 4.4437. Okay, and if we thought of it as a percentage, it'd be like 44%. Okay. Next one. What's the probability to make the first and miss the second? Well, probability make, I'm going to use a little different notation, and miss. Make 0.85, miss 0.15, multiply 0.1275. Okay. All right, next one. What's the probability he'll make the first 3 free throws and miss the 4th? Okay, so make 3 in a row. So I'm going to think of it as 0.85 to the third, make 3, miss the fourth, use your calculator, 0.0921 is the probability that he would make 3 and then miss 1. Okay, all right, the last one. What is the probability that he'll make at least 1 free throw? Okay, shooting 5, so he's shooting 5. So at least 1. Well, this is extremely difficult, okay? That means he makes 1, or he makes 2, or he makes 3, or he makes 4, or he makes 5. So if we thought about this as straight probability, I would have to find all the possibilities that he make 1. So that means he makes the first one, misses the next 4. Okay, so it'd be like, you know, think of it like this. If I came up here and it'd be like, make, miss, 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 miss. That's just one possibility. Or miss, make, miss, miss, miss. So it'd be ridiculous to calculate all of that. All right. It's possible, but it's extremely hard. All right. So let's think about the opposite instead. The opposite of making at least 1 would be missing all of them. So missing all of them would be the complement. So if we calculated this as a complement, it becomes a whole lot easier. So if I thought of this as 1 minus the probability miss 5, so 0.15 to the 5th power, subtract that from 1, and then he has a 0.999 chance of making at least 1 because we use the complement. Okay, that is much, much easier. All right, so let's talk about a little bit of notation. Okay, in other situations you might see the following. The probability of A, capital U or big U, means or. All right, and then above I did mention and. There's your and notation. Okay. All right, and then I have a formula that we need to learn for what's called conditional probability. Conditional probability. Okay. Basically, the probability of an event will occur given another event has occurred. Okay, so probability that the second roll on a dice is a 4 given the first one was a 6. Okay, so let's talk about that formula for a minute. Okay, so the notation is probability of event A given B. Okay, that notation is given. And the formula is you take the probability of event A and event B and you divide that by the probability of event B. Okay. So learn the notation. Learn the notation. Okay. All right, let's go to the next page. Okay, example 7. All right, so we can get into some little bit different types of probability here. It says in a group of 100 sports car buyers, 40 bought alarm systems, 30 purchased bucket seats, and 20 purchased an alarm system and bucket seats. If a car buyer chose at random bought an alarm system, what is the probability they also bought bucket seats? Okay, all right, so let's talk about our events. So alarm systems, I'm going to make that event A. Bucket seats, event B. Okay, so the probability of event A only would be 40 out of the total, which is 100. All right, so we got 40 out of 100, so we got 0.4. The probability of event A and event B is 20 out of 100 is 0.2. Okay, and then we got a probability of event A and event B divided by the probability of A. So if I divided those, I get 0.5. Okay. All right. And that would be, A and B would be the condition that they, bought an alarm system given that they also bought bucket seats. That's how conditional probability. So this formula right here is your formula for conditional probability. Okay. All right, so we're going to look at a contingency table. So this contingency table has males and females and pets and no pets. All right, so I'm going to finish filling in the contingency table. Okay, so the point, you just add up the rows, add up the columns. If you did it right, the total of both would be 1. Okay, so the question is, what is the probability that a randomly selected person is male given that they own a pet? Okay, male given they own a pet. So the probability that they're male given they own a pet. So we do need to use the formula for conditional probability. Male and pet divided by probability of a pet. Okay, so male and pet would be 0.41 from the table here. Okay, probability that they own a pet, okay, is the 0.86, that bottom number there, and then divide those, you get 0.4767. All right, so notice, hopefully you're noticing the math is not hard, but the reading and the notation is probably what's going to trip you up a little bit. Okay, all right, suppose we flip a coin 4 times and record the number of tails. Are all the outcomes equally likely? It means they all have the same chance. Yes, all the outcomes are equally likely. Okay, suppose we flip a coin 1 time. Find the following. Okay, all right, so let's talk about 1 time first. Probability of heads. Well, pretty simple, 1 out of 2. Probability of the complement of heads, not heads, 1 out of 2. Okay, probability of heads or tails. 1 flip, heads or tails. Well, 1. It's going to happen. You're going to either it's going to be heads or it's going to be tails. All right. Well, let's talk about you flip a coin 2 times. Okay, on the second flip. All right. So the probability of heads, given that the first one was tails. All right. So we flip a coin 2 times. So I'm going to use something to illustrate this that's called a tree diagram. Okay, so my first flip, we got heads or tails. Okay, and then I'm going to branch this off. And my second flip, heads or tails. All right, so heads, given the first one was tails. All right, so if we calculate this, okay, probability of heads and tails is 1, and then the probability that there's tails, all right, is given that the first one was heads. So let's think about this. So first one's tails, so that would be here, okay, and then the probability that the second one's tails, so that would be here, all right. So that means your path are those 2. So I'd have to say 1/2 okay, let's use our formula. So I'm going to use conditional probability of heads and tails over the probability of tails. Okay, so heads and tails, all right, well, that can't happen, all right. So it's really hard to think of it using the formula here. So we really do need to use that tree diagram. All right. So heads given the first one's tails. All right. So that means the first one has to be tails. So that is 1/2 is that probability. Okay. And then the second one is tails given the first one's heads. Okay, so that probability there is also 1/2. So it's 1/2 times 1/2, which is that 1/4. Okay. All right, the next few, we're flipping a coin 4 times. All right, we're going to flip a coin 4 times. So I think I have enough room to make our tree diagram out to the side. Okay, so I'll show you what this would look like, 4 flips. So we got our first flip, heads, tails. Second, third, and then finally my 4th flip. Okay, let's see why I left so much room down here. Put that one a little lower. All right, so it asks for heads, heads, heads. There's only one way that this happens is this one right here, heads, 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 heads. Okay, so basically 1/2 to the 4th power, 4 times, 1 out of 16. Okay. Now, let's look at the sample space, okay? So the sample space is all possible outcomes, all right? Well, that means we would have to write out all of these, okay? And there's, a lot of them, all right? So if you think about it, if we're, 2 to the 4th power is all your possible outcomes. So I'm going to start writing this out. So I'm going to start with heads. Heads, 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 tails. And you could definitely come up with this sample space without a tree diagram, but I would tell you this, it's much easier with the tree diagram. Because in my experience, very, very easy to leave one of these possibilities out. And if we want all of the possibilities, it's easy to follow the tree diagram. Get one more in here. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm missing one. Let's see. Oh yeah, the second one is tails. I don't have that one. So I need heads, tails, heads, heads. All right, so those are the 16 you should have. All right, and you just get that from the path here. All right, it's basically, heads, tails, heads, heads. All right, that's the best, easiest way to get it is follow the path of the tree diagram. All right. All right, what's the sample space for the number of tails? So we're going to think of the sample space for what number of tails there are. Okay, so there could be 0 tails, there could be 1 tail, 2 tail, 3 tail, or 4 tail. Well, the sample space, for 0 tails, all right, is 1 out of 16. That's the probability that would happen, 1 out of 16, okay? one tail, okay, one tail happened 4 times out of 16. Okay, two tails happened 6 times out of 16. 3 tails happened 4 out of 16. And then finally, all 4 tails happened 1 out of 16. Okay, if you're asked for sample space for a specific event, okay, those are all the possibilities. All right. The next one, we have what's called a 4-sided die, has the faces 1, 2, 3, 4. So only 4 sides. All right. So let's talk about the sample space. All right. So easy way to do the sample space would be to make a table here. All right. So I'm going to add a page. All right. And thought I was going to add a page. Blank. Here we go. So let's talk about what that sample space would look like. So we have 1, 2, 3, 4 are the possibilities. Okay, and we're rolling a 4-sided die. All right, has the faces. All right. So what are the possibilities for the outcomes? Okay. Well, if we're rolling it twice, okay, then we're going to have, I'll show you how to organize this. So 1, 2, 3, 4 on one die, 1, 2, 3, 4 on another. So we could have 1, 1, 1, 2, 1, 3, 1, 4, okay, 2, 1, 2, 2, 2, 3, 2, 4. This is definitely the easiest way to write what the sample space is. Okay, so those are all possibilities for rolling 2 dice. So that's the answer to A. Okay, all right, question B, what are the probabilities of each outcome? All right, so what are the probabilities of each outcome? All right, and we're going to talk about the sum. Didn't say, but the sum, all right? Well, we have a sum of 2. Okay, a sum of 2. Well, that happened 1 time, 1 out of 6. Or not 1 time, but yeah, it did happen 1 time. Okay, sum of 2. All right, 1 out of 16, not 6, 16. Talk about the probability of 3. Okay, it happened twice, and I'm not going to reduce right now. That's 2 out of 16, so you can see it. The probability that the sum is 4. Well, it happened 3 times. Okay, we're looking at the probability that the sum is 4. It happened 3 times. This diagonal row right here, those are the 3 times that it happened. Okay, the probability that the sum is 5. 4 out of 16. Sum is 6. Happened 3 times. 3 out of 16. Sum is 7. Happened 2 times. And then finally the sum is 8, and it happened 1 time. 1 out of 16. Okay. And then it has one specific question. What is the probability that the sum is 5? Okay, well, we have it right there. 4 out of 16, which is 1 out of 4. Okay. All right, last question. It says there are 4 blood types in the USA. They have the following distributions. Type A is 42%, type B 10%, type O is 44%. So the only one we're missing is type AB. Okay, you do some arithmetic, figure out how much is left. Only 4% have type AB. That's the first question. What is the probability of type AB? Well, 4%. What is the probability a person does not have type O? 1 minus 0.44, 0.56, okay, or 56%. And honestly, I don't really care how you write probability, whether it's a decimal or percentage. You might even want a reduced fraction. Who knows? Okay. All right. And finally, example 9C, Maria has type B. She can safely receive blood from people with O and B. What is the probability that a randomly chosen American can safely donate to Maria? Okay, well, probability that someone has type O or type B, 0.44 plus 0.110 equals 0.54, which is 54%. Okay, all right, so great thing about a video is you can watch it as many times as you want.